Hello guys, welcome to the DMS Online School. In today's video, we are going to revise Science Paper 1. This is the paper which was written on the 31st of July 2023. It reads Examinations Council of Zambia, Examination for General Certificate of Education Ordinary Level. This paper was written by the 2023 GCE candidates. If you are new to this channel, you are most welcome. And on this channel, I teach mathematics, science, biology, civic education, RE, English also, and revise past examination papers, just as I'm doing in this video. So if what I do on this channel is what you're interested in, consider clicking the red subscribe button below and turn on the bell notification so that when I upload a new video, YouTube will notify you, because if you don't subscribe, you will not be notified when I upload a new video and you will miss out. Without further ado, let's go straight into the revision. Okay, so section A, 20 marks, meaning that section A of science paper 1 consists of 20 multiple choice questions, of which each question carries 1 mark. It reads, answer all the questions on the answer grid provided. A1, the following diagram shows a vernier caliper with its jaws closed. Okay, this is the vernier caliper here, as you can see, and the jaws are closed. These jaws here closed, and also here they are closed. Then the question says, what is the zero error of this vernier caliper? What is the zero error of this vernier caliper? For you to be able to answer this question correctly, you must understand what the zero error is. So here are some few definitions of zero error. So the first definition says, zero error of a measuring device is the error that occurs when the device shows a non-zero digit or a non-zero reading when it should actually show 0. Okay. The second one says, in other words, it is the error that occurs when the measuring instrument registers a value even when there is no input or quantity being measured. Yeah. So what it means with the zero error is that it is a measurement which a measuring instrument indicates or reads without measuring any quantity. Like here, this one is not measuring any quantity, but they want us to show the reading on it. So the reading is given by this formula. Reading is equal to ms plus vs, MCLC. Okay, so ms is an abbreviation for main scale reading, and vs is an abbreviation for vernier scale reading, and LC is an abbreviation for least count. So you need to get values which you need to substitute here: main scale reading, vernier scale reading, least count, for you to know the reading here. So where do we get the main scale? So you must understand the parts of a vernier caliper. Like up here, this scale up here is what we call the main scale. This one here, up here. And then this one down here, this scale here with these numbers down here, is the one we call the vernier scale. Okay. So we needed to read the main scale here. So we put the value here. The vernier scale here, we put the value here. The least count is a standard value which depends on the units being used. So when reading the main scale here, you read a value or a mark that occurs before the 0 mark on the vernier scale. So you start from 0, you read going this way until you find this mark which comes before the 0 on the vernier scale. This is the 0 on the vernier scale, but this is the mark here which has appeared before actually this 0 here. So this mark is where you read from. So this is 0, 0.1, 0.2. So meaning the vernier scale, the main scale is actually 0.2. The units is centimeters. Then for the vernier scale, you read on this mark here, the mark which coincides with a mark on the main scale. So when you check on the main scale, there is this mark here, and then on the vernier scale, there is this mark here. So these marks are coinciding, or rather lining up in a way that they look like they are in a straight line with each other. So this mark which makes a straight line with this mark here is the one you read the reading from. So how do you read? You read from 0, 1, 2, 3. So that mark is at 3 units. So meaning the vernier scale is 3. So you start substituting. You say equals many scale, it is 0.2 centimeters, then plus, then VS, which is vernier scale, it is 3. You put 3 times least count. For a vernier caliper in centimeters, it is always 0.01 centimeters. Then you say equals, you get this value, put it as it is, you say plus, first multiply 3 times 0.01 centimeters, where you get 0.03 centimeters. Then you add 0.2 centimeters plus 0.03 centimeters, you get 0.23 centimeters as the answer. So the answer here is actually D. This is the reading which is shown here as the 0 error, meaning it is the value which this apparatus or device is reading even when it is measuring nothing here when the jaws are closed. Okay, so we move to A2. A2 reads 4 objects E, F, G, and H of different masses were placed at places with different gravitational field strength. Which object has the largest weight? Okay, so we have 4 objects here, E, F, G, H, which have got different masses. This one 8.0, this one 8.5, this one 9.0, this one 9.5, and these were placed at different places with different gravitational field strengths. So this one was placed at 10.4, this one at 9.8, this one at 10.2, this one at 9.5. So as they placed them like that, they are asking to say which object has the largest weight. So that the object with the largest weight must be found. First of all, you need to know how to find weight. Weight should be found by multiplying mass times acceleration due to gravity. So you are going to get the mass of each object. You try to multiply it with the acceleration due to gravity and see the weight it is going to have. So you see here there's weight for this object. Here it's acceleration due to gravity. Here weight, I mean mass. Here there's mass for this object. This is acceleration due to gravity mass. So for us to find the weight, I added a column here which I indicated as weight in Newton. So I'll be getting this value times this value, meaning I'll get mass, put it here, times gravity there. So I'll get this times that, I'll get this value. 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 Now, since the question says which object has the largest weight, so when you compare this, it is this one here. So we go to A3, says according to drops from the top, a coconut drops from the top of a palm tree 20 meters high. If air resistance is neglected, how long will it take the coconut to reach the ground? Take G equals 10 Newton per kilogram. Okay, so they want us to find what? If air resistance is neglected. Okay, if air resistance is neglected, then they say how long will it take the coconut to reach the ground. So they want time. How long is time? So this is the formula which we use for finding time when an object is thrown. So this is the formula. H height is equal to initial velocity times time plus half times acceleration due to gravity times time squared. Now you need to know that for an object thrown downward, initial velocity is equal to 0 at the point of throwing, and acceleration due to gravity is equal to 10 meters per second square. This simply means that for an object thrown downward is the same as an object which it drops. So in that situation, initial velocity is 0. So if we get 0, we put here, we say 0 times time, it will be 0. So this one equation becomes H is equal to, so this part will be 0, you know it will remain with this part here, which is half times gravity times squared. Now you start substituting because you are given height as 20, so you get 20, you put here is equal to half, then times gravity, which is 10, you put there times time squared. Then what you do, you say 20 is equal to half times 10, which will be 5 meters per second squared times time squared. Now you're looking for what? For time. So you divide this side by 5 meters per second square and this side 5 meters per second square, so that once you do that, you must realize that this and this will cancel, then this and this will cancel. Then you say now you come this side, so you have made this subject of the formula. It will be t squared is equal to, then you say 5 into 20, you get what? You get 4, then you remain with the seconds square, this one here. Now you rewrite this one. Now since you are looking for t, not a t squared, you square this side and square this side, so that this square and square root will go. So you remain with time is equal to the square root of 4, it will be 2. The square root of square times s square, it will be s. So the answer will be 2s as time. So the answer is A. Then you go to A4. A4 reads, the following diagram shows a uniform meter rule in equilibrium when different masses are hung on either side. So what we have is a uniform meter rule which is in equilibrium when different masses here are hung on either sides. So the question says calculate the value of mass x. Calculate the value of mass x. So this is the value they want us to find, the value of mass x here. So what we are going to do, for us to be able to find the value of x here, we must use the principle of moments, because this question is coming from moments. Since it is coming from moments, we will apply the principle of moments. So the principle of moments says moment on the left side here, which is ml, is equal to moment on the right side on this side here. You must know that these things which are hung here can cause this one to move down like this, and this which is hung here can cause this to move like that. Now if it is balanced, meaning what can cause it to rotate in this direction here is equal to what can cause it to rotate in that direction. That's why we are saying moment on the left is equal to moment on the right. So this formula can be expanded by saying force acting on the left times the distance of that force acting on the left from the pivot should be equal to the force Fr acting on the right times the distance of that force from the pivot. So D stands for the distance of that force from the pivot. Now in our situation here, this is a general formula. Now the question which we have been given doesn't directly fit in unless you begin thinking. So first of all, we are going to label this. This one will label it as a force R. Okay, if we want, we could label it MR, doesn't matter, but I decided to label it for force R. Then the distance of force R from the pivot is this distance here. We label it dr. So this is the pivot. This is where this object stands. So this is its distance. Then we move. We have again this distance here, which we can call d1, because there are so many there are two objects. There are this object and this object. So now I've started naming the distance of this object from this pivot here. I mean of this mass from the pivot here. I'll call it d1. Okay, and this one here, the force which is produced by this mass, I'll call it F1, so that these move accordingly. Then I'll go to this distance from the pivot up to here where this mass stands. I'll call it D2, and this one, the force, I'll call it F2. The force caused by mass 10 gram is F2. So you see, on this side we have two objects, this, and their distances from the pivot. So since there are two, now to find the proper formula to use to answer this question, you are now going to say F2, this one, times its distance from the pivot here, which is D2. Then you have finished, you shift to this, so you need to say plus, then F1 times its distance from the pivot. This F1 here, its distance is here, then you say equals, then this one, it is as it is, F, okay, R times dr. Then you begin substituting. Where there is F2, you put what? 10 grams times, you get this one D2, which is from here up to there. So from here up to there, it is this distance from here, 10, plus from here 30, which will be 40 total. So this is the 40. Then you get plus, then F1, it is actually this one here, 20, then times D1, it is from here up to here, which is from here up to here, 10. Okay, then equals FR is actually X here. So you put X times DR is actually 40 centimeters here. So you put 40 centimeters. Now, if I were to get my calculator here, let me get my calculator here, so that I show what I did. So on your calculator, to punch this one at once, you say open brackets, you will say 10 times 40, close brackets, then plus, you come to 20 times 10. Okay, so 20 times 10, okay, you close brackets, then you say equals. So on this side I found that it is actually 600 centimeter gram equals, then X times 40 centimeters, it will be actually 40 centimeters X. Now what we are looking for is X, so divide by 40 centimeters, even here by 40 centimeters, so that this centimeter and this centimeter can go, 40 also can go, then this centimeter and this centimeter can go. So you say now 600, okay, divided by 40, you will get what? You will get 15. Okay, so here the answer will be 15 with this gram here is equal to X. So when they said calculate the value of mass X, so X is equal to 15 grams, which is C here. So we move to the second question. So the second question, F5, reads, a bullet passes through a wooden block 0.8 meters thick. The velocity of a bullet reduces from 700 meters per second to 300 meters per second as it passes through the block. If the mass of the bullet is 10 grams, calculate the work done by the bullet in kilojoules. Okay, so work is given by force times distance. Okay, then when we look at this question here, we can't see force, but we know force can also be found by force is equal to mass times acceleration. Still, we can't see acceleration being provided in this question, but we know that acceleration can be found using this formula. Final velocity squared is equal to initial velocity squared plus 2 times acceleration times AC distance. So this equation, it's where we are going to start from. So this 700 is actually initial velocity when they say the velocity of a bullet reduces from 700 meters per second to 300 meters per second. So this becomes initial, this one becomes final. So we are going to say only the final here, velocity final, it is 300 squared equals initial velocity, it is 700 squared plus 2 times acceleration, which we don't know, times AC is the distance that the bullet moved in a block, because here we are told a bullet passes through a wooden block 0.80 meters thick. So this is the distance it will move in the wooden block, which is 0.8. Now, if we were to evaluate everything here, your answer should be acceleration equal to 250,000 meters per second. Now, for those of you who cannot see how this was solved, let me just do it for you so that you also move at the same pace with me. So what we did here was like 300 squared. So say 300 squared, you get 90. So you get 90 like that, 1000, okay, equals, then 700 squared also there, like that, we get 490. So is equal to 490,000, as you can see. Then here plus, then you multiply 2 times a times 0.8. So 2 times 0.8 actually, which was 1.6a. So 1.6a. Now we are looking for a. So this one will move this side. So it will be 90,000, okay, minus 490,000, okay, which will be equal to 1.6a. So if you say 90 like that, okay, minus 490 like that, okay, you get what? Negative 400,000. So you get negative 400,000, okay, like that, equals 1.6a. Now what you are interested in is a, so you divide by 1.6 and here 1.6. So if you divide this answer by 1.6, you get this one here, negative 250. So here you have negative 250,000. Then it will be actually acceleration. Now it is in negative because it is deceleration, but it doesn't matter. We can give it a positive as 250,000 meters per second. Since it is acceleration, whether it is in a deceleration or get the value of positive. So this is how this value here was found. Now after you find that value, what will come next is to now substitute. You say force is equal to mass times the acceleration. So you say equals mass. If the mass of the bullet is 10 gram, so the bullet is 10 gram, this gram you convert it to kg. You divide by 1000 for it to go to kg. So if you get 10 grams divided by 1000, it will go to 0.01. Yeah, so that's what it is going to be. So here the mass will change to this 0.01, then it times acceleration, it is this one here, then you multiply this times this, you get 2500 newtons. So this one becomes the force. So once you find that one as the force, so you come now to here where you say equals force. Now it is 2500 times distance. This is the same distance which the bullet moved in. So you say 0.8. So you multiply 2500 times 0.8, you get 2000 joules. Now they said the work should be in kilojoules. So you divide this one by 1000 to change it to kilojoules so that it becomes 2 kilojoules. So the answer will be B here. Guys, if you're enjoying this video, please give it a like and also let me know in the comment section. If you haven't subscribed, consider clicking the red subscribe button below. Turn on the bell notification, because doing so will enable YouTube to notify you when I upload a new video. But if you don't do that, then you will be missing out some of the latest videos which I will be uploading on my channel. Again, for those interested in online lessons for GCE 2024, you can call me GCE lessons, okay, for 2024, you can call me on or WhatsApp me on 097 92 41 75 so that you can be enrolled for GCE online lessons for science, English, biology, mathematics, civic education, RE. So science is at 120. These other subjects are 60 kwacha each per month. Alright, so let's proceed with the revision. Alright, so A6 says an elevator ascends at a constant speed of 1 meter per second. The total mass of the elevator is 1000 kg. Take gram to be equal to 10 newton per kg. Calculate the power required to raise it to this speed. Okay, so they're saying there is an elevator, okay, which ascends at a constant speed of 1 meter per second. The total mass of the elevator is 1000 kg. They're saying calculate the power required to raise it to this speed. We know that power is equal to work over time. Okay, but when we check in this question here, you cannot see work, but we know that work can also be found using force times distance. But again, we don't have force here, but we know that force can also be found using force is also equal to weight, and weight is equal to mass times gravity, okay, or acceleration due to gravity. So meaning that we'll say power is equal to, where there is work here, we shall put force times distance, then over time. Then we'll say, okay, power is equal to, but when you check here, we don't have force and we don't have distance. If you will check anywhere here, there is no distance. So what we are going to do is to realize that this, if you factor out this, okay, let me just do it properly here. If you factor out this value d is the same as velocity, which is the distance over time. So this you factor out d over t as velocity, so that now after factor out that one, so that you have force, this is force, this one becomes velocity. Okay, so all this value you have replaced it with velocity. Then you say, okay, power is equal to, now this one here is also, this force is equal to weight, which is equal to this. So you say where there's F, you put this here. So it will be mg times velocity. Why are we doing this? Because these are the values which we have in the question. If you look, velocity is here. Constant speed and velocity are the same, of 1 meter per second. So that's why we have picked it there so that we use it. Then mg, there we have mass, which is this one here, and then we have acceleration due to gravity, this one here. So this now will work. So you substitute mass, which is 1000, times acceleration due to gravity, which is 10, times velocity, which is 1 meter per second, meaning it is 1. If you multiply 1000 times 10 times 1, you have 10,000 now watts, because we are looking for power. Power is in watts. So when you check from the answers provided here, the answer is C. We move to A7. A7, which says the following diagram shows a pulley system. So this is a pulley system with effort applied here, and then here we are told there's F. It says if a man using the pulley system pulls the rope at E 16 meters downwards, how high will the load F rise? Okay, if the man now, they're saying pulls the rope at E here, so that this effort moves 16 meters downward, how high will the load, this one here, rise? How high is it going to rise? So the labeling these guys used were actually wrong. Load, usually we use this L here. I don't know, because L goes with E. L is for load, okay, that's what I know. And then E is for what? Effort. That's how we always do these things here. Okay, but I don't know why they like changing, though we know that these are forces. but I don't know why they changed them like that, maybe to confuse you. Now, if they say, how high will the load F rise? So, since they are looking at distances, meaning you are dealing with a velocity ratio. Velocity ratio, which is abbreviated by VR, V velocity R ratio, is equal to dE, which is distance moved by effort, over dL, distance moved by load. Now, you must know that the velocity ratio in this pulley system is already given. It is equal to the number of strings connecting the upper pulley and the lower pulley. So this is the upper pulley, this is the lower pulley. The number of strings connecting the two are 1, 2, 3, 4. So meaning velocity ratio is equal to 4. Okay? How many? 1, this one here, 2, this one here, 3, this one here, 4, this one here. It can also be found by calculating or counting the pulley. This is 1 pulley, 2 pulley, 3 pulley, 4 pulley. So the velocity ratio is equal to 4. Then distance moved by effort here is equal to 16 meters, because they said that if a man using the pulley system pulls the rope at E 16 meters downwards, it means E will move 16 meters. Then DL is what we don't know, which is the distance that the load will move here, which will be question mark. Now, once we do this, we will substitute where there is VR, we'll put 4 is equal to, where there is DE, we'll put 16 meters over, then DL, which we don't know. Then we'll make this one DL the subject of the formula. So we said over 1, then we'll cross what? Multiply. So we'll say 4 times DL, it will be 4 DL is equal to 1 times 16 meters, it will be 16 meters. Now we'll divide by 4 so that we get rid of it, even here by 4. So that 4 into 4, it will cancel. Then 4 into 16, it will be 4. So here we remain with DL, 4 into 16 meters, it will be actually 4 meters. So the answer will be B here. Now we move to A8. What is the main reason why food is cooked faster in a pressure cooker than in an ordinary pot? Okay, so some of these are some of the general questions which come from thermophysics and properties of matter. So the theory which I will give you here is that a pressure cooker, what is it? A pressure cooker is a sealed pot that traps steam inside. This increases the pressure inside the pot, which raises the boiling point of water. This means that the water in a pressure cooker can get hotter than the water in an ordinary pot, which cooks food faster. So here when they say, what is the main reason why food is cooked faster in a pressure cooker than in an ordinary pot? So the answer is C. The boiling point of water is raised here. Raises the boiling point of water. So the answer is C. Then A9 says, in a thermos flask, a vacuum reduces heat transfer. What method or methods of heat transfer is or are reduced by the use of a vacuum? So let me give you also this theory. The use of a vacuum reduces heat transfer by convection and conduction. Convection is the movement of heat by a fluid such as air or water, and conduction is the transfer of heat by direct contact between two objects. A vacuum is a space with no matter, so there is no fluid or contact to transfer heat by convection or conduction. Okay, so we have looked at how a vacuum reduces heat. It reduces heat transfer by convection and conduction. Why? Because convection in the first place is the mode of transfer of heat in fluid, okay, or is the movement of heat in fluid such as air or liquid. So in air, you find that there are particles there in air. Then also in liquid, there are particles there. Conduction is the movement of heat by direct contact of two objects. So even in conduction, you need matter. But vacuum is a space with no matter. So how can conduction and convection transfer heat in vacuum where there is no matter? Not possible. So when they say what method or methods of heat transfer is or are reduced by the use of a vacuum, it is convection and conduction. B is the answer. If we move to A10, which feature of a liquid in glass thermometer increases its sensitivity? The feature of a liquid in glass thermometer which increases its sensitivity is actually here A, which is narrow capillary bore. Then A11 says, which of the following diagrams shows the correct path of a ray? Which of the following diagrams shows the correct path of a ray of white light passing through a glass prism? Okay, so they want us to see from these diagrams A, B, C, D, the one which shows the correct path of a ray of white light passing through a glass prism. Now, you must be able to apply the laws of refraction here. Refraction, when light passes from a more dense medium to a less dense medium, or when light passes from a less dense medium to a more dense medium. At the boundary here, for us to know which one will be the correct answer, we must draw the normal here. When we draw the normal, we must look at this ray as it passes from air into the prism. Is the ray of light bending towards the normal? The ray of light should bend towards the normal, but in this case it is bending away from the normal here. Okay, so which is wrong? Equally here, if we draw here a normal, here it is correct, a ray of light has bended away from the normal, which is supposed to be the case. So on B here, we have to draw also a normal here and another normal there. So a ray of light, when it passes from a more dense medium to a less dense medium, from a less dense medium to a more dense medium, the ray must bend towards the normal, of which here it has bended towards the normal. And when a ray travels from a more dense medium to a less dense medium, it bends away from the normal. So here it has bended away from the normal. Okay, so this one is the almost correct answer, but let's observe here. Here, if we draw, if we draw a line here, a ray from a less dense medium to a more dense medium, it should bend towards the normal, but it is bending away from the normal. Here again, if we draw a line, a ray should bend away from the normal, which is making sense, but this kind of a situation, no, it should bend actually away from the normal, yeah, which is correct, but this is again wrong. Here, if we draw a line and here, you find that here the ray of light is not bending, and here, which is not true. So the correct answer is B. If we move to A12, which says the following diagram shows a transverse wave. So this is a transverse wave with the vertical axis representing displacement and the horizontal axis representing time. Then the question says, how many complete waves are shown in the diagram? Okay, so you must understand that a complete wave is a wave that if it is connected, it makes a complete circle. Okay, so like from here and here, if you connect this part here and this part, you can make a complete circle. If you shift this part and bring it here to make a complete circle, so from here up to here you have wave 1, from here up to here you have wave 2, from here to here you have wave 3. So there are 3 waves in this diagram, so the answer is B. A13 says the following diagrams show 2 waveforms. Let me push it here. The following diagrams show 2 waveforms. We have this waveform here, displacement time. Okay, then this one also we have displacement time. The question says which property of sound waves is different in the two waves? Which property of sound waves is different from the two waves? Okay, so when you check what we have here, we have 0, 0.1 and 2, 0.2 here, 0, 0.1 and 0.2. But in the displacement here, we have 4 as the highest displacement. Here we have 3 as the highest displacement. So what we can see, the amplitude is different on these two cases here. Okay, what we see is the amplitude is different. Here the amplitude is the distance from the equilibrium to the maximum. So here amplitude A is actually 4 centimeters. Okay, then here the amplitude from there to there is actually A equals to 3 centimeters. Now this amplitude here, what does it affect? Does it affect frequency, loudness, pitch, or quality? Amplitude affects actually loudness here. So meaning the property of sound waves is different. Which property of sound waves is different in the two waves? It is actually loudness here. So F14 says, which statement is not true about a magnet? It is always A, attracting magnetic materials near it, but we are looking for a statement which is not true. Okay, but it is always attracting magnetic materials near it. Yeah, so magnets attract magnetic materials near it. Then B, made from magnetic material, not true. Then C, made up of two opposite poles at its end, yes. Then D, resting in the north south direction when suspended freely, yes. So of all these, the correct answer is B, because it's not always that magnets are made from magnetic materials. This is the reason here. The statement is not always true. Okay, while many magnets are indeed made from magnetic materials, there are also magnets known as permanent magnets that can be made from materials like iron, cobalt, and nickel. However, there are also magnets called electromagnets that are created by passing an electric current through a coil of wire. The magnetic field generated by the flow of electric current gives rise to magnetism in materials that would not be magnetic otherwise. So you find that these electromagnets also produces magnetic properties. So they are also called magnets, and they are not made from magnetic material, but they are made from current flowing through a wire, and in this case the wire can be copper wire, which is non-magnetic material. We move. So A15 says, which diagram correctly represents results obtained when a charged gold leaf electroscope is brought close to a charged metal rod using the method shown? So here there are two things that you must look into very carefully. We are told which diagram correctly represents results obtained when a charged gold leaf electroscope. So there is a charged gold leaf electroscope is brought close to. Again, we have another one, charged metal rod using the method shown. So here we have two things here, charged gold leaf and also charged metal rod. Okay, so remember, if an object is charged, meaning it has only one type of charge on it, it can either have one positive charge, or it can have one type of charge as positive charge, or the other type of charge as a negative charge. So if I look at these situations here, I came to look at this question as one of the questions which had also errors in it, because there was no any questions which was making sense apart from A. So for me, the answer I gave was A, because for B, if a gold leaf is charged, let's say if it is charged with a negative charge. If it is charged with a negative charge, if you bring a metal rod which is charged negative, there will be no way that on this side here it will remain with positive. Never. Because it had only negative charge. So in this case, they mean that when they brought a metal rod which was charged negatively, all the electrons were repelled this side and then positive charges remained this side, which this case represents a situation if the gold leaf was not charged. But if the gold leaf is charged, if it is charged with negative, when you bring another negative metal rod here, what happens is divergence. These, they will just diverge to indicate that whatever you are bringing there has got the opposite, has got the same charge as the charge on the gold leaf. Okay? Then when we come to this situation here again, you see, here we have positive here, then up here we have negative, which means that if they brought a negative here, there is no way that it will have negative here, because negative and negative will never be the same. And also it doesn't make sense that if the gold leaf was charged with one charge, there is no way it can have positive here and negative here. No way. Equally here, no way it can have negative and positive charge here. No way. Okay, so the correct answer is here. This answer shows that, let's say the gold leaf was charged with positive. So even if you brought another positive metal sphere here, it will maintain. Okay, it will maintain because all electrons here are removed. Electrons have been removed, so if you bring it here, it will maintain. But what you are supposed to see, these are supposed to diverge. Okay, to show that the charge on the metal rod is the same as the charge on the gold leaf. So the correct answer for me here is actually A. We move to question A16, which says the following diagram shows a cathode ray oscilloscope CRO with a bright spot formed from an AC generator. Okay, so this is actually a screen of a cathode ray oscilloscope, and they're saying there is a bright spot formed when an AC generator is connected to it here. So what we are seeing a vertical, horizontal sweep, and also a vertical sweep. Now if they say which part of the cathode ray oscilloscope brings the movement observed. Now for me, what I know is that if it was connected to the AC generator and there is a sweep like this and a sweep like this should produce something like this. Okay, so these are some of the questions which had errors for me. These questions had errors. So it has to show a sweep like this because the AC generator creates a sine wave like this. This is a sine wave which it creates on a cathode ray oscilloscope screen. So this sine wave can be brought by to the X plate and the Y plate. So if they say which part of the cathode ray oscilloscope brings the movement observed, it should be both the Y plate and the X plate. So the answers here were two. If one put A, they can get it correct. If they put B, they can get it correct because there was an error in this question. Then we go to A17, which says study the circuit diagram shown. So in this circuit diagram, we have 8 volt here. We have ammeter. We have the 2 volt. We have the 2 ohms resistor, 2 ohms resistor here also, and the X resistor there. Then the question says calculate the value of resistor X given that the ammeter reading is 2.5 amps. So what they want is to find the resistor X here, given that this ammeter reads the current of 2.5 amps. Now, for us to calculate the resistor here, we need to know first voltage here across this. Okay, you need to know voltage across this resistor here, and also voltage across these resistors in parallel here. Okay, so
you know, here we have voltage total. Here our voltage total is 8. So what we can do to find this, we are going to say voltage total is equal to, here we can call this one as voltage 1 and this one voltage 2. So voltage total, voltage in, you see here, this resistor here and these are in series. So you have voltage total is equal to the voltage here and voltage here. So we are saying voltage total is equal to voltage across resistor 1 plus voltage across these resistors in parallel, which we are calling voltage 2. Now voltage total is 8 equals, now this voltage here, it can be found using this formula, total current passing and the resistor. So total current passing here times resistor 2 here. We can call this one as resistor 2 because it has a 2 there. Then plus voltage across here also can be found by the total current which is flowing here and the total resistance here. Okay. Then once we do that, we'll say 8 is equal to, we'll see here we have total current, here total current. So we'll factor out total current, open brackets, here will remain with R2 plus R total. Now what we want is to get rid of this. So divide by current total, also current total, so that this current here can go with this. So that what we are going to do is to have R plus RT is equal to this one here, 8 divided by IT. So I've just cancelled this. I have picked this, which is this one, equals this one has come this side. So that we start substituting. We say R2, this one here, it is this one I named R2. So I'll put the actual value 2 plus RT, we don't know it, equals, it is the one we should look for, then equals this 8 over current total is 2.5 amps. So 2.5 amps. So you say 2 plus RT equals 8 divided by 2.5, you get 3.2. So now you say equals RT is equal to 3.2 minus, this one crosses there, so 3.2 minus 2, then you are going to remain with equals to this minus that, you have 1.2. So we have seen that the total resistance is actually this one here. So this is the total resistance here. Very important that we know the total resistance. Once we know the total resistance here, what we are going to do is to find use this formula which says, let's say this one we call it resistor 1, this one resistor 2. Remember this formula which says total resistor is equal to resistor 1 times resistor what? 2, then over resistor 1, okay, plus resistor 2. This is the formula for total resistors in parallel. So we'll use this formula. So we'll say, okay, total resistance R is equal to, here resistor I got it as X as it is, then times here 2, okay, this one here over, then here again I got as X as it is plus 2 here. Then here total resistance is already 1.2, so I had to put 1.2 equals, I said X times 2, it will be 2X. Okay, I never actually multiplied, I just substituted, right? So X times 2 over here, I had to put X plus 2. Then from here, what I did was this, because here it is actually 2x is equal to 1.x plus 2.4x. So from here I came to this stage. Now one who is not strong in mathematics will not understand how I arrived at that. So what I did was 1.2 equals x, okay, times what? Times 2 over here x plus 2. So I said over 1 because I want to get rid of the fraction. So I said 1 times okay, before I can even go to this level here. So what I did first of all was to do this, to say okay, 1.2 is equal to So you say x times 2x, it will, I mean x times x, you get 2x. Then here you remain with x plus 2. Then here I said over 1 so that I can get rid of the fraction. So 1 times 2x, I got 2x, then equals 1.2 times x here, it will be 1.2x, then I got plus here, then I said again 1.2 times 2, I got 2.4. This is how I arrived at this point here. Because of space here, I was actually cutting out some of the processes because of space. So from here you make x the subject of the formula, so you get 2x, you collect like terms, this come 1.2 equals, you remain with 2.4. So 2x minus 1.2x, you remain with 0.8x is equal to 2.4. Then you want x to divide by 0.8 here. So here what I did was to divide by 0.8 so that I remain with x, also here to divide by 0.8 so that now it will give me equals 3. So this is a 3 ohms, okay, which means the answer was actually D there with our required answer. We move to A18, which says study the following diagram. So this is the diagram. It says what name is given to the electrical device shown in the diagram. So when you look at this electrical device shown here, you will notice that it is a transformer. So a transformer consists of the coil. This coil here, the first coil here is called primary coil. This one is a primary coil. Then in the second coil here, it is actually called secondary coil. Now, if the primary coil has got many coils, okay, on the primary side you have more coils than on the secondary. It means the transformer is a step down transformer. As you can see, there are many coils this than here. So when they say what name is given to the electrical device shown in the diagram, the answer is a C, step down transformer. Okay, so we move to A19, which says which radiation is used to increase the shelf life of fruits and vegetables. Okay, the radiation which is used to increase the shelf life of fruits and vegetables is actually gamma rays. Okay, then A20 says iodine is a radioactive substance with a half-life of 8 days. What fraction of iodine will remain after undergoing a series of disintegration for 32 days? Okay, so here we are dealing with a radioactive question, and in this radioactive question, what we can see is that we are told that iodine is a radioactive substance with a half-life of 8 days. So it has 8 days as a radioactive substance. Then they're saying what fraction of iodine will remain after undergoing a series of disintegration for 32 days. Okay, so the formulas which are there, which we use to calculate questions like this, are these. Number one, total time is equal to number of half-lives times half-life. Then another question is 2 to the power number of half-lives is equal to original amount over final amount, or 2 to the power number of half-lives is equal to original activity over final activity, or initial activity over final activity. Now, these formulas here can be combined into one. So you can have this formula which says final amount is equal to initial amount times half times total time over t. So this one can also be written as like this: A is equal to A like that, then open brackets 1 over 2, then you can say T over T like that. Okay, so this is final activity, initial activity. Okay, so now having such kind of information, first of all we need to know what we are provided. we have half-life of 8 days. So say half-life is 80 days. Then we have 32 days. 32 days is total time. Okay. Then what they're asking us is N. When they say what fraction of iodine will remain after undergoing a series of disintegration. So we'll say question mark. We don't know what will remain here. Okay. Now, for us to answer this question well, we will assume, because when you look at these questions here, they want the what remains. So, but we don't know what was given. So we assume that the amount which was given or initial amount was 1. You can assume it to be any number, but me, I have decided to use 1 so that it will be simple for me to do the calculations. So I have assumed that the initial amount of this iodine was actually 1. It can be either 1 gram or 1 whatever, so it is 1. Then I'm now going to use this formula here to do it at once. So what I'm going to do is to say what I'm looking for is N. So say N is unknown is equal to initial amount is 1. I'll put 1 here times 1 over 2. Then time, which is total 32. Then half-life, which is small t here, it is 8. So it will be 32 over 8. Then I'll say now remaining amount is equal to 1 times everything here. You know 1 doesn't affect everything. So I'll have actually the same thing. So I'll say 8 into 32, it will be actually 4. So here I'll have 1 over 2. Then I'll say 8 into 32, which will be 4. So here I'll come this side. I'll say, okay, is equal to 1 to power 4. It is just 1 over, then 2 to power 4. I'll say 2 to power 4. Then I'll say equals. Then I'll say 1 over 2 to power 4 is 16. So meaning the amount which remained is 1 over 16, meaning the answer is C. So if you are enjoying this revision, give it a like if you haven't done so, and also let me know in the comment section there. Alright, so for those interested in online lessons for GCE and also grade 12 internal for 2024, WhatsApp me on the line, which is 0977 then 92 41 75. So this is the line you can call or WhatsApp me if you want to study online or to learn online for 2024 grade 12 GCE. Alright, so let's proceed with the revision. Okay, this is section B, 45 marks. Answer all questions in this section. Write your answers in the spaces provided in this question paper. B1 says a learner carried out an experiment and obtained the following results as shown. Where necessary, take density of water equal to 1 gram per cubic centimeters. Mass of an empty bottle is equal to 80 grams. Mass of the bottle full of water equals to 20 grams, and mass of the bottle full of liquid X is equal to 25 grams. Okay. Then A, they're saying name the instrument that can be used to obtain the results of mass. So the instrument which we can use to measure mass is actually either electronic balance or beam balance. But in this technological world, you can either say electronic balance or digital balance. The beam balance is no longer in use, so we need to phase it out. This one here is no longer in use. Okay, so you can say electronic balance or digital balance. Okay, we are no longer in history. Okay, we are in now the 21st generation, and whatever we are using in the 21st generation is what we should mention. We shouldn't mention the beam balance, which is now outdated. Okay, so now here they are saying calculate the volume of the bottle. Okay, so to calculate the volume, we need to know first of all what we are provided. We are told mass of an empty bottle, it is 80 grams. Mass of the bottle full of water, it is 20 gram. Then mass of the bottle full of liquid X is 25 grams. So from the look of things, if they say calculate the volume of the bottle, meaning we need to calculate, we need to know the formula which has got a volume, which is this formula here. Density is equal to mass over volume. So we'll make volume the subject of the formula. So it will be volume is equal to mass over density. Now, if we are calculating the volume of the bottle, we need to know the volume, right? So the volume of the bottle, this is where you need to think. Science requires thinking. So science is not like what, it is about thinking. So here they have tricked this question. So let's assume this is the bottle. We have a bottle like this. Okay, I'm assuming this is the bottom. So the volume of the bottle will be equal to the volume of the liquid or water which will fill it. So once we know the volume of the liquid which will fill the bottle, meaning we know the volume of the bottle, that is the thinking here. You see how they trick you? This is how they trick. When we say passing science originally doesn't depend also on the teacher. This is what we mean. It also depends on the thinking capacity of the pupil and also on the experience of the pupil. Okay, based on this experience and thinking, this is why we offer online lessons, so that your capacity of thinking is increased. And this is why I offer a revision package for past paper revision, so that you see as many revision past papers as possible. Once you see as many revision past papers as possible, your thinking capacity is going to be built, or it's going to be increased. Your logical thinking will be increased, your critical thinking will be increased, so that you will be able to notice that for you to calculate the volume of the bottle, it's just calculating the volume of the water, because the volume of the water is equal to the volume of the bottle inside. So in this case now, we'll just calculate the volume of the water, because it will be the volume of the bottle. So we'll say, okay, for us, we are told mass of an empty bottle is 8 grams. Then mass of the bottle full of water is that. So first of all, to calculate the volume of the water, we need to know the actual mass of the water. So we know that the mass of the water is going to be mass 2, which is mass of water and bottle, mass of the bottle full of water, minus M1, which is just mass of empty bottle, which is 8. So say, okay, equals 20 minus actually 8, which will give us actually 12 grams. So now we know this. Again, we know that density of the water is equal to this one here. So the symbol for density is this, not that, is equal to 1 gram per cubic centimeter. So this is the density. So we'll substitute from here. Volume is equal to mass 12 grams over density, which is 1 gram per cubic centimeters. So this gram and this gram will cancel. Then you say 1 into 12, 12. Then you remain with cubic centimeters. So the answer here will be volume is equal to 12 cubic centimeters. So this is the volume of the water, which is also equal to the volume of the bottle. Okay, 12 cubic centimeters. Then we'll move to see, calculate the density of liquid X. So they want the density of liquid X. That's what now they want, the density of liquid X. So we'll look for the density of what? Of liquid X, as it were. So when we check here, mass of the bottle full of liquid X. So we need to see, for us to find the density of liquid X here, first of all, we need to know what is the mass of liquid X. But here they're saying mass of the bottle full of liquid X is equal to 25, meaning in this mass 25, there are two masses. One, the mass of the bottle, two, the mass of liquid X. So to just know the mass of liquid X, we must get first this minus the mass of the empty bottle. So that's how we work here. So say density is equal to mass over volume. Then mass is going to be mass of the bottle and the liquid X minus mass of empty bottle, which is going to be equal to mass of liquid X and bottle is 25 minus mass of empty bottle is 8. So if you say 25 minus 8, you get 17 grams. Then you say equals, you know, we are looking for what? The mass. So the volume of the density, I mean, so the volume will be equal to what we found previously. So the volume will just be the same volume which we found here, because this liquid X is going to fill up the bottle, so it will occupy also the volume here. So the volume of this liquid is still 12. So say mass is equal to 17 divided by 12 cubic centimeters. Then once you divide, the density will be 1.4 cubic centimeters, which you put here. Then you move to question B2, which says figure B2.1 shows the same cone being placed in 3 different positions, X, Y, and Z, on a flat surface. So we have cone X in a position X, position Y, position Z of the same cone. Then F, they are saying define center of mass. Center of mass is defined as the center of mass is the point on a body where the whole mass of the body seems to be concentrated. So the center of mass is the point on a body where the whole mass of the body seems to be concentrated. Yeah. So we move to B, identify the cone in a neutral equilibrium. So the cone in a neutral equilibrium is this one here, Y. So we'll come here, we'll say cone labeled Y. Then C says state 2 factors that affect stability of an object. So the 2 factors that affect stability of an object are 1, position of the center of mass of the object, then 2, base area of the object. Then we move. B3 says figure B3.1 shows the direction of 4 forces acting on a car whose weight is 8,000 Newton as it travels in a horizontal straight line. So we have this car here, and it has actually 4 forces: force A, force C, force D, and force B. Then A, they're saying which 2 forces should be equal for the car to move at constant velocity. Okay, this is the theory you need to answer this question. So we're saying for the car to move at constant velocity, there must be no net external force acting on it. This means that the forces acting on the car must be balanced. In other words, the sum of all forces in any direction must be 0. Yeah. So for the car to move with constant velocity, meaning the addition of all the forces acting on this must be 0. Now, since the car is moving in a horizontal straight line, so meaning if the car is moving in a horizontal straight line according to this, they're saying it travels in a horizontal straight line. So we only need to consider the forces in the horizontal direction. So this is the force in the horizontal direction, and this. There are force FB and force D. So there are force B and force D, which are pointing to the right and left respectively. So when they say which 2 forces should be equal for the car to move at a constant velocity, are these ones here, because the car is moving in the horizontal straight line, and these are the ones in that direction. So you say force B and force D. Then we move. B says the following table B3.1 shows sizes of forces acting on the same car after it had covered a certain distance. Okay, so there's a force A 800, force B 1000, force C 8000, force D 600. Then they're saying calculate the part 1 mass of the car. Okay, so we were told that a car whose weight is 8000. So we know the weight of the car. If we know the weight of the car, it is easier for us to calculate the mass using the formula weight is equal to force times the acceleration due to gravity. So weight is equal to mass times acceleration due to gravity. Okay, yeah, that's what we are going to use because we have been given weight. So we'll make mass the subject of the formula. So mass will be equal to weight over acceleration due to gravity. Then we know mass will be equal to weight is 8000 Newton over acceleration due to gravity is 10. So if we divide these, we are going to get 800 kg. So this one and this one will cancel. So we'll have 800 kg as the mass. Now part 2, they're saying we calculate the resultant force on the car. So resultant force, which I can put like this, should be equal to the square root of the forces in the x component squared plus the sum of the forces in the y component. That is the general formula here. So what I did, because of space here, I did the forces acting in the y axis. Like here there's this force and this force, which is force A and force C here. Force A and force what? C. If when I added them together, they gave me a certain value. Then also the forces acting in the y, in the x-axis, are this force and this. When I added them, they gave me a certain value. So now I had to put here and here. That's why I had this FR, which is the resultant force, is equal to, I said, these forces, I had 400 squared plus 7200 squared and square rooted them, and this gave me an answer of 7211 Newton, which is our resultant force. Now, according to this question, when I looked at that marking key, what I saw was that their answer should have been like they subtracted 1000 minus 600, where their answer was like should have been 400 Newton, which was wrong. That was not the resultant force, because they had to put this one. The mark was actually 1 mark. The answering of this question does not deserve 1 mark. It deserves more than 1 mark, like 3 marks. This question here deserves about 3 marks at maximum and 2 marks at minimum, not 1 mark. They had to put 1 mark because in the first place they put a wrong answer there, because they just did 1000 minus 600 to get a 400 Newton, which they thought was going to be the answer, which was not true. So we move. Then part 3 says acceleration of the car. So the acceleration of the car will be force is equal to mass times acceleration. Acceleration is equal to force divided by mass. Now acceleration is equal to the force. We have found it as 7211 Newton over the mass was found to be 800 kg. So if you divide here, acceleration is going to be 9.0 meters per second square. So you put your answer there. We move. B4 says figure B4.1 shows a crane of Figure B 4.1 shows a crane at a construction site raising a steel block of mass 100 kg through a vertical height of 16 meters in 20 seconds. Okay, there is a crane which is raising a block, a steel block, this one here, of mass 100 kg from the ground. Okay, all right, there's a chain there going like that, and that is a pulley. Then power input 1000 watts. Yeah, then they're saying calculate the part 1 work done by the crane. Okay, you must know that work is equal to force times distance. When we check here, there is no force. All right, so you must know that, but in force we know that it is equal to also weight. Okay, force is equal to weight, and weight is equal to mass times gravity. So meaning that we are going to substitute to say, okay, work is equal to, where there is a force here, we are going to put mass times gravity times distance here. Then we'll substitute work is equal to mass of that steel block is 100. You put 100 times gravity. Here, even when they didn't give it to us, we use 10 times the distance is actually the distance this steel block moves from the ground, which is actually 16 meters. Then you multiply everything here, you get like work will be like 16,000 joules. So you put 16,000 joules. Okay, if you are enjoying this video, guys, give it a like if you haven't done so, and let me know in the comment section. Make your comment in the comment section there. And if you're interested in the GCE online lessons for 2024, you can contact me on the number 0977924175. Also, for grade 12 online lessons, contact me on the same line. 2024, we have already started. Don't miss out. The earlier, the better. All right, so let's proceed. We come to part 2 here, which says power developed by the crane. So we need to calculate the power developed by the crane. But we know that power is equal to work done over time. Okay, now let's see. Work, we have calculated it at 16,000 joules. Now what was the time here? So let's check for time in this situation. So the time here was actually 20 seconds. So we'll go there and divide by time 20 seconds. So if you divide 16 joules by 20 seconds, you get actually 800 watts. So the power here will be 800 watts. Now B says, given that the power input to the motor is 1000 watts, calculate the efficiency of the crane. Now efficiency is equal to power input over power output, okay, which is equal to times 1000, I mean 100%, which is equal to power output is what actually we have calculated here, the power which is developed by the crane. So it is actually 800 watts over the power input is this one that have given us 1000 watts times 100%. Then if you evaluate this, you get 80% here as the power, I mean efficiency. Then we come to this question B5, which says figure B5.1 is a graph showing the variation of temperature in degrees Celsius with a time second when frozen water is heated for some time. So here, vertical axis we have temperature, horizontal axis we have time. Then this graph here shows the variation of frozen water when it is heated for some time. Then they said A, what physical change was happening to the water at the point labeled A? So this question was wrong when they said at point A. A physical change cannot occur at one point. It occurs within a range of time. So at one point, what time has elapsed here? Nothing. So it should occur from 0 up to here. So the question was supposed to be like, what physical change occurs between point A 0 and A there from here? So the physical change occurring from here to point A here, it is actually melting, because frozen water is melting here from there to there. Then in B, when they say in which state is the water at the point between A and B. So between A and B. So once water melts here, from O to A, it is melting here. So here there's actually melting in this process. Once it reaches here, it has already completed melting. So the graph again starts going like that. So from A to B, the state is actually liquid. It has already melted. So here you have liquid here. So there is a liquid. So the answer here is liquid. Then we move. Then C, they're saying when the temperature starts to rise, the volume initially decreases and then increases. State the reason for this observation. So we are going to say this is because liquid water has high density and less volume than frozen water and steam. So as the temperature increases, frozen water changes to liquid with less volume. As the temperature of liquid water continues to increase, the liquid water changes to steam with high volume than liquid. So yeah, this is why we see that the volume initially decreases and then increases, because solid water has more density, has less density, high volume, while liquid water has high density, low volume, while again gas or water vapor has got actually less density and high volume. That's why we see those changes, like there is volume goes like that and then it goes like that during the heating process. Yeah, so something like that. We move. So B6 says figure B6.1 shows a ray of light traveling from glass to air at an angle. The refractive index of glass is 1.52. Okay, then this is a ray of light moving from a glass to air. So this is semicircular glass block. Okay, this is normal. Yeah, once it reaches there, it is refracted. It goes like that. Okay, then here they are saying define critical angle. So critical angle is the angle of incidence in a denser medium which gives the angle of refraction in the less dense medium equal to 90. Yeah, so the angle here, this angle here is what we call critical angle. So critical angle is the angle in the dense medium, like the glass block here, for which, or which gives the angle of refraction in the less dense medium equal to 90. So the angle of refraction here, it is this one here, not this one they gave here, it is this one here. So it is refracted here, so this angle of refraction is 90. So if this angle in the dense medium causes the angle of refraction to be 90, then this angle in the dense medium is called the critical angle. That's why we are saying critical angle is the angle of critical angle is the angle of incidence in a denser medium which gives the angle of refraction in the less dense medium equal to 90 degrees. Then remove. They are saying B, calculate the critical angle in figure B6.1. So critical angle is found using this formula. Refractive index is equal to 1 over sine critical angle. So we make critical angle the subject of the formula. We say sine is equal to 1 over refractive index. Will continue. So critical angle will be equal to sine inverse 1 over refractive index. Then we'll substitute. So sine inverse is equal to 1 divided by refractive index here. See, the refractive index is 1.52 here. Okay, 1.52. So that is where I've gotten that 1.51 divided 1.52. If you evaluate this, your answer should be equal to 41.14 degrees. So your critical angle should be 41.14 degrees. Then you see they're saying state two conditions for total internal reflection to occur. So number one is that the light ray must travel from a more optically dense medium to a less optically dense medium. Then 2, the angle of incidence must be greater than the critical angle. Then D, Give one application or use for total internal refraction. So one possible application is in optical fiber. Yeah, we move. B7 figure B7.1 shows an AC generator with its many components labeled A and B. Okay, this is an AC generator with its main component labeled A and B. Then write down the names of the components A and B. So what is the name of component A here? So the name of component A here, it is actually strip rings. Then the name of component B here is actually carbon brushes. Then we move. B, state 3 factors that increase the magnitude of the electromotive force EMF produced by the generator. So one factor, number one, is turning the coil faster. Then the other factor is increasing the strength of the magnetic field. Then 3, adding more turns to the coil. So these are some of the things that increases the magnitude of the electromotive force, turning the coil faster, and also increasing the number of the magnetic field, or increasing the strength of the magnetic field and adding more turns to the coil. Okay, we move to B8, which says figure B8.1 shows an electric circuit with a 5 um, ohm resistor R connected to a 12 volt supply. Okay, we have actually here a 12 volt, a 5 ohm resistor R, and we have a voltmeter here and an ammeter here and a switch. Then they're saying state Ohm's law. So we are going to say Ohm's law states that the voltage across a conductor is directly proportional to the current flowing it, provided temperature remain constant. Yeah, this is Ohm's law. Then B part 1 says calculate the reading of the instruments labeled A and V. So we need to calculate the reading of the instrument labeled A, ammeter, and labeled V, voltmeter. So the instrument labeled A, which is ammeter, measures the current. So for us to calculate current, we'll use the formula voltage is equal to current times resistor. Then we'll make current the subject of the formula, which will be voltage over actually resistor. Then we'll substitute, we'll say current is equal to voltage that have given us, it is 12 volts, as you can see, divided by resistor here, which is 5. So if you divide 12 by 5, you get your current as 2.4 amps here. Then we come to this one here, V, voltage. So they want now voltage here, right? So this is what they want, the voltage here. We calculate voltage here. So we'll use the same formula here, which says voltage is equal to current times resistor. But current, we have calculated it to be 2.4. Resistor there, you see the resistor which is here, it is 5. So use the same 5 there times 5, then it will give us 12 volt. So the answer is 12 volt. Then part 2, they're saying what is the cost of using resistor R for 6 hours a day for 30 days if power costs 15 ngwe per kilowatt hour. So what is the cost of using resistor R for 6 hours a day for 30 days if power costs 15 ngwe per kilowatt hour? Okay, so the cost is found by power times time times rate. Okay, power times time times rate. If you want, you can also say cost is equal to energy times rate, because energy is equal to power times time. However, I had to use direct there. So cost is equal to power times time times rate. So rate is cost per a unit. Like here, cost is 15 ngwe per kilowatt. So this is a rate. Now, in this question, we need to calculate first power. Power is equal to current times voltage. Okay, so current, okay, put voltage times current. So voltage is 12, current was what? 2.4. So if we multiply here, we get 28.8 watts. Now power, when used in when it is used in homes, it is measured in kilowatts. So you divide this by 1000 so that you get 0.0288 kilowatts. So we know power here. Now time, how long was the resistor used? For 6 hours a day for 30 days. So what you are going to do here to find your correct answer, you just do like this. You say, okay, it was used 60 hours, 6 hours for 30 days to know the total time, which is 180. So the time is 180. So you start substituting equals power. I've found it is this one here. Okay, times time 180 times rate, which is 15 ngwe per kilowatt. So you write 15 ngwe per kilowatt. Now you must know that now this hour and this hour will cancel. This kilowatt and this kilowatt will cancel. You remain with ngwe. So when you multiply this 0.0288 times 180 times 15 ngwe, the answer you are going to get is 77.76 ngwe. So this will be the cost, 77.76 ngwe. Okay, we move. So we come to B9 here. Says figure B9.1 shows radiations P, Q, and R passing through an electric field. Okay, so this is an electric field, and we have radiation actually, which is P, Q, R, that is passing there. Here it is radioactive source, so this is where it is coming from. And then they're saying A, identify the emission P and Q. We identify P and Q, then B, give one use of emission Q. So for you to be able to know what these are, you must actually know this fact here, that if you have field pointing into the page like this, and then you have negative charge passing, like a negative charge passing, using a right hand rule says that if the first finger here, this is the first finger, points in the direction of the field, then the second finger point in the direction of current, then the thumb will point in the direction of force. So when you have an electric charge moving in that direction, like moving here going this way, you consider it as a current moving in opposite. So since this one is pointing downward, this one is pointing into the page, then this one will go downward like that. So that's what you should know. This theory is very important to apply it here. So that's why you are seeing a negative charge is going like this, a positive charge like that. Then this one without charge continues to go straight. If they say identify the emission P and Q, so this P here, which goes this way, it has positive charge. The emission which has positive charge, there are three emission: gamma rays, then there's particle, alpha particle, and beta particle. So alpha particle are positively charged, then beta particles are negatively charged. So this one which is positively charged, which goes like that, it is actually the alpha particle. Then this one which is not affected by the field, it just penetrates straight, it is actually gamma ray. Now if they say B, give one use of emission Q, which is gamma ray, you can say to sterilize medical instruments by killing bacteria. We move. Here, see, they are saying mention two differences between emissions P and R. So they want us to mention two differences between emission P and R. So what are the differences between emission P and R? First place, emission P is a helium nuclide because it is an alpha particle. An alpha particle is a helium nucleus or nuclide. Wow, this one is actually a fast moving electron. This one here, R, is actually a beta particle. A beta particle is a fast moving electron. So let's move and look at our question. So number one, we are saying P is a helium nuclide while R is a fast moving electron. Then second, P is positively charged while R is negatively charged, as you can see there. Okay, so this one positively charged, this one negatively charged. Okay, then we move to section C, 20 marks. Answer any two questions from this section. In the answer provided answer in the separate answer booklet provided. C1, figure C1.1 shows a velocity time graph of a car of mass 1,200 grams. So this is velocity, this is time. Then they are saying A, calculate the acceleration of the car in the first 2 seconds. B, explain why the acceleration is 0 meters per second squares between 2 seconds and 4 seconds. Then C, calculate the displacement of the car while its velocity was increasing. Then D, calculate the resultant force on this car during its acceleration. Then E, distinguish between speed and velocity. Then F, calculate the displacement of the car for the whole journey. Okay, so what we have seen here is they want us to first of all calculate the acceleration of the car in the first 2 seconds. So the first 2 seconds that this acceleration happens when the graph is going upward like that. An upward straight line gives us acceleration. So the vehicle is only accelerating between this point and this point. Between this point and this point, there's constant velocity and zero acceleration. From this point and this point where you have a downward graph straight line, it is deceleration or negative acceleration or retardation. So to answer this question first, we have C, A. So acceleration is equal to final velocity minus initial velocity over time. So if we come to this information of ours here, so here is initial velocity we read, then final velocity where it reaches here we read from here 30. Then in time it is from here to here 2. So we will substitute here. So same final velocity is 30 minus the initial 0, then over time 2 seconds. When you evaluate this, you get 15 meters per second square, because 30 meters per second minus 0 meter per second, it will be actually 30 meters per second. Then divided by actually 2 seconds, you get 15 meters per second square as the answer. Then we go to B. B here they're saying, explain why the acceleration is 0 meters per second between 2 seconds and 4 seconds. So you come here, you say the acceleration is, you say the acceleration is 0 meters per second square between 2 seconds and 4 seconds because the car is traveling at a constant velocity. Okay, we come to C. C here says, calculate the displacement of the car while its velocity was increasing. So we calculated the displacement of the car while its velocity was increasing here. From this region to this region, we need to find the displacement. So displacement is equal to the area under the graph, because they're saying calculate the displacement of the car while its velocity was increasing. This is the region in which the velocity was increasing, and the displacement is equal to the area under the graph. So the area under the graph is equal to the area of the triangle. Okay, so now the formula for the area of the triangle, which is equal to the distance or displacement, is equal to here. So we'll say distance or displacement is equal to half base times height. So you come here, you realize that base is this one here, from here to here 2, height is from here to here, which is 30. So base is 2, height is 30. So what you do here, base, you say half, base is 2 times height is 30. So 2 into 2, it will cancel, you remain with 30 meters there. Okay, so this one and this one cancels, you remain with 30 times 1, it is 30 meters as your displacement there. Okay, then we go to D. So when you come to D, it says calculate the resultant force on this car during its acceleration. So we need the resultant force here when it was accelerating, but we know the mass is here, so we'll use this formula here. We'll say force is equal to mass times the acceleration, where we know that mass is this value here, 1200. Okay, so we'll say 1200 times the acceleration was 15 meters per second square. When you multiply here, we'll find that the resultant force is going to be 800 or 8000 Newton. Then we come to E. If we come to E here, it says distinguish between speed and the velocity 1 Mach. So you can either say that speed is the rate of change of distance while velocity is the rate of change of displacement, or you can say speed is a vector, a scalar quantity, while velocity is a vector quantity. Then we go to F. F says calculate the displacement of the car for the whole journey. So displacement of the car for the whole journey from here up to there is equal to the area under this shape here. When you look at this shape, it is a trapezium. So the area of the trapezium is given by half, open brackets, A plus B, close brackets, H. So if we come here, you realize that A is from here to here. This is what we give A here. From here, so from here to here it's A. From here to here it's actually B. Then from here to here it's actually H. So from here to here it is 4 minus 2, it is 2 here. Then from here to here it's 8. From here to here it's 30. So we'll come back and change. So say equals half. So here it is open brackets 2 plus here I said 8. Then H is 30. So if you evaluate everything here, you say your answer will be 150 meters. Okay. Then we move to question C2, which says table C2.1 shows data collected from an experiment to determine the resistance of a conductor. Okay, so this is the data collected from an experiment to determine the resistance of a conductor. So voltage, we have these values, current, we have these values. Then A, plot a graph of voltage against current. B, use the graph to estimate the resistance when the current is 5 amps. Then C1, does the conductor obey Ohm's law? Then 2, justify your answer. D, what term is used to describe such type of conductor? Then E, give an example of a conductor that behaves like that. Okay, so start answering. So C, 2A, what we need to do there, it is to do what? Plot a graph of voltage against the current. So that's what we are going to do. So bring the graph, which is the voltage against current. So here we'll label this one voltage, then this one vertical axis will label current. So whenever they tell you to say plot a graph of voltage against current, meaning voltage should be on the y-axis and current on the x-axis. That's the order. What comes first on the y-axis, what comes next on the x-axis, always. Okay, that's what you should do. No. Next, you need to put the values here. So bring the data table, the table containing data. Now, the secret here, it is to make sure that the values you put here, they will be the values that will accommodate the highest value. The highest value you have is 8, right? Then the lowest value you have is 0. So you put the values here to ensure that they accommodate everything here. So if we start from 0, I can even say 10, 20, 30, 40, 50, 60, 70, 80. So meaning that I will accommodate all the values here. Then on the current side, the highest value I have 12 here. So I'll put my values to ensure that I accommodate all the values here. So I say this one I'll put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you see, I will accommodate everything here. So now, if you want, you can put what they call a scale, which doesn't really matter. A scale where you say, okay, in this case, a scale is that on the y-axis from here to here, actually it is 2 centimeters. When you measure with a meter rule, it is 2 centimeters. So you're going to say on the y-axis, 2 centimeters has been given 0 to 10 units. So you say 10 units. Then you come to on the x-axis here, you see from 0 to 1 here, it is also 2 centimeters. So 2 centimeters. So you say From 0 to 1, we have given it 2 centimeters. Here has been given 1 unit. So you say 1 unit. This is what we call a scale. So once you do that, then what you are going to do is to start plotting now. So you begin plotting, like here, you begin plotting the values of 0, 0 here. 0, 0 is here. The next 2, 4. So 2 is here. Then 4 is here. So you count 0, 1, 2, 3, 4 here. So 4 you move to 2 here. Then you come to 4, 10. 4 is here, 10 is here. You put a point there. Okay. Then you come to 6, 16. 6 is here. This is 10 here. 11, 12, 13, 14, 15, 16 there. So you follow this 16 up to 6 here. Then you have 8, 26. So 8 is here. 20 is here. 20, 21, 22, 23, 24, 25, 26. So you follow that one. You find that it is there. Then you have also 10, 42. So 10 is here. 40 is here. 41, 42. So you come here. 42 is there. Then you go to 12, 8. 12, 8 is there. 8 is there. Then you draw a smooth line like that. Okay. Then we go to another question here. So question B says use the graph to estimate the resistance when the current is 5 amps. So when the current is 5 amps, what will be the resistance? That's the question here. So you come here, you come on the current where it is 5 amps here, you draw a line. When it hits the graph, you bend, you go there, okay? So here where it hits the graph and it bends, it is at 13, 10, 11, 12, 13. It hits at 13 volts. Here you are reading volts. So you come here, you say, okay, there I've read it to be C2B. You say, okay, current was 5 amps, which we were told. Then voltage, you have found that it is 13. Now resistor is what they're asking for. So you say voltage is equal to current times resistor. Resistor is equal to voltage over current. Then you say equals, you put voltage is 13 divided by current 5. Then you get your answer as 13 divided by 5 as 2.6 ohms as your answer. Okay. Then we move to this other question here. C part 1 says, does the conductor obey Ohm's law? No, that conductor doesn't. So say here, part 1, no, it does not obey Ohm's law. Okay. So 2 here says, justify your answer. So here we'll put the answer. We'll say, this is because voltage through the conductor is not directly proportional to the current, or because the graph is not a straight line. As you saw, the graph wasn't a straight line. Yeah. So that is the reason why it does not obey Ohm's law. If the graph was straight line, then we would say it obeys Ohm's law. But since the graph is not a straight line, it doesn't obey Ohm's law. Then we move to the other part of the question. D, what term is used to describe such type of conductor? So the term here, we are going to say, term is non-ohmic conductor. Yeah. Then the last question here says, give an example of a conductor that behaves like this. So an example is a semiconductor. Then we move to the next question, C3, which says figure C3.1 shows an apparatus used by a grade 12 learner to detect radioactive emissions. Background radiation was among the emissions detected. So here radioactive source, here detector, counter. Then A part 1 says state what is meant by background radiation to give one example of background radiation. C, table C 3.2 shows the results obtained from the experiment after taking account of background radiation. Okay, count rate, counts per second, per minute, these are the values. Time, minutes, these are the values. Then they're saying plot a graph of count rate against time. Then part 2, they're saying from the graph determine the half-life. Then part 3, what fraction will have decayed at 140 minutes. Then C, they're saying a nucleus of uranium that emits one alpha particle to form thorium, that one. Write an equation for this decay. Okay, so to answer this question first, they're saying, first of all, what we need to do on this one is to part 1 state what is meant by background radiation. So here we are going to say background radiation is radiation that is present or detected in the absence of a radioactive substance. Okay, then part 2, they're saying give one example of a background radiation. So we are going to say cosmic rays. Okay, then we come to B, where they're saying plot a graph of count rate against time. So we are plotting a graph. So we'll come to this place where we'll plot a graph B1. We'll put a graph. So we are plotting a graph of count rate against time. So we'll label the axis here. So this one should be count rate in count per minute. Then this one will be actually time in minutes. Then we'll bring the data. This is the data given. So as I said, the values that we should put here must be able to accommodate the largest value on the count rate, which is 200. So we'll start with 0. We'll say 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200 there. Then the values we put here also here must be able to accommodate the largest value, which is 120. So here we'll put 0, we'll say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Okay, once we do that, we'll start plotting. We'll start plotting 0, 200. So 0, 200 is that point there. Then we'll say 30, 100. So 30, 100 is here. Then we'll plot 60, 50. So 60 is here. 50 is between 40 and 60. So it is actually down here. Then we have 90, 25. So 90, 25 is somewhere here. 25 after 30 is somewhere there. 25 is in between here. Okay. Then we have 120, comma 12.5. So 120 is here. 12.5 is down below somewhere here. Then you draw a line like that. Okay. Now, once you do that, let's go to the other question. It says from the graph determine the half-life. So when you come to the graph, half-life is determined when you get the original count rate here, which is 200. The half of the original count rate is here. So you come on the half, which is 200, 100. You draw a graph. When it touches the graph here, you drop down here where it points at time 30 minutes. This 30 minutes is the half-life. So you say half-life is 30 minutes, which we had to put here that B2 half-life is 30 minutes. Then we come to this other question here. They're saying what fraction will have decayed at 120 minutes. So at 120 minutes, what we see is that 12.5 would have remained. Now what is going to have decayed at that point? So we will say the fraction that would have decayed is count rate, 20 count rate minus 12.5 count rate. So if you remove this one from there, what would have decayed is actually 185.7.5 count rate. Yeah. So we move. Okay. Yeah. This is where we are going, right? Yeah. C. So C, here they're saying a nucleus of uranium, that one emits one alpha particle to form thorium, that one. Write an equation for this decay. Okay, so To write an equation for this decay, this is the general equation which guides you when writing alpha decay. When you have a parent nuclide, if it decays by alpha, its daughter nuclide, its mass reduces by 4, its atomic mass reduces by 2, and it releases an alpha particle which is a helium atom or nuclide. So in this case, you are given uranium, which is 235 and 92. If it undergoes alpha decay, what will happen is it will form thorium. So the thorium will be the daughter. So its relative atomic mass, or its mass here, will be the reduction of this one by 4. If you reduce by 4 here, it will be 231. And if you reduce this one by 2 according to here, it will be 90. Then plus a helium particle here which has a 4 and 2 here. Yeah. So we have come to the end of this actually revision. Thank you very much for watching. I hope this one has been helpful. If you haven't subscribed, consider clicking the red subscribe button below and turn on the bell notification so that you don't miss any of my upload. If you don't want to subscribe, don't, but you'll be missing any new of my upload. All right. And then the other thing is, for those interested in online lessons, it is 0977924175. This is the number. This is the number 0977924175 for online GCE lessons for 2024 and internal grade 12 lessons for 2024. As for now, bye and see you in the next revision. Peace.